So we have today easy problem. This given the string of the binary digits 0, 1, 0, 1, we want to find minimum number of operations to make it alterating. So the alterating strings are only two variants. First is 0, 1, and second is 1, 0. Given that we know there are only two possible targets, we can just check them independently. And the default solution looking like this. Just count for the first event and count for the second event and then do the minimum. Now let's start with the interesting part. And the interesting part is golfing. Let's start from the simplest one. So we first notice that we can only count one variant, and the second variant we get automatically it's just length minus the first count, because they are mirror of each other. Now, what else can we do with this knowledge? There is a mathematical solution possible. However, it's not. It's still O of 1 of n, and we still should calculate something. Instead of calculating for the variant, we calculate the balance. And the total number of chapters is correct positions plus wrong. And when we calculating for the balance 0, 1, 0, 1, like this, we look at if it match the first wave like 0, 1, or the second wave like 1, 0, and then we do calculate the balance. If it match, we do +1. If it doesn't match, we do -1. Now let's look at the code. So if it matches, like even positions matches with zeros, and odd positions matches with ones, we do balance +1. And if it doesn't match, we do -1. So this is kind of, if we all match with wave type 1, we will get all ones, and the sum will be equal to length. Then we just have to calculate length minus length would be 0. And if it matches with the other one, we still get same length, and this is absolute value gives us the same length minus length, it will be 0. And only if it doesn't match, we get the balance. The balance is how many chapters it doesn't match with either one or the second one wave. So this is like the balance. Yet if it's a match with the first type, going up. If it matches with the second, going down. So this is not so if it's total match, total type 1 0 1 0 1 type, and the minus value is total 1 0 1 0 type. So this, the final distance, is the number of wrong positions. And now let's look at other kind of golfing I made. Another type of golfing is that you can skip the check of parity, because the 0 SI code and 1 SI code have different parity. You can just do plus the current plus current index and then take the parity, and it will be the same, so a little bit shorter variant. And another interesting fact is that we shorten this as U8. So U8 is 8 bits or single byte value, and the I is size. And when we do this shortening, we still have preserved the last 8 bits. So it's totally fine to do this kind of conversion. So I think that's it for today.